Today we're going to talk about the rational zero test. This is for my students. It's in their page 175 in your book. But if you don't have the book, I'm just going to explain what the rational zero test is. The rational zero test is used to identify rational, and just so you know what rational is, that means fractional real zeros. All right, fractional real zeros. So when you talk about the rational zero test, we're going to be finding rational real zeros by using this formula, P over Q, all right, P over Q. So when you have P over Q, it is important to know that P are the factors of a constant of a polynomial, are all the positive and negative factors of a polynomial, of the constant. Q is the factors of the positive and negative factors of the leading coefficient. So when you have here, it's probably put positive and negative, all right, factors, positive and negative factors of the leading coefficient. So to help you understand how this works is we're going to go through an example right now of how to use the rational zero test to determine possible rational zeros. Well, here's an example. What we have is we have a polynomial. This polynomial is x cubed minus 4x squared plus 9x minus 6. And what we're going to use is we're going to use the rational zero test to determine the possible rational zeros. Okay, so that means real fractional zeros, all right, not irrational. Now, we're going to do this by using P over Q. Now, P over Q, I probably need to give myself a little bit more room. Move this down here. We'll come to those just a little bit, all right, is that when we have this, we're going to take P over Q. Now, P is referring to all of the constant terms. Okay, so this will look positive and negative factors of a sub 0. A sub 0 in this case is 36. So we're going to write this out, all right, this value. So we have plus or minus 1, and then we get plus or minus 36. We have plus or minus 2, and when we take out 2, we get plus or minus 18. Okay, then we go plus or minus 3, and then we get plus or minus 12. And I'm running out of room. Move this over here. All right. Make sure you always give yourself enough room when you're writing these out. All right. Then we go plus or minus 4, and then we get plus or minus 9. And if we go plus or minus 6, and we come to our n. So those are all the factors of 36, our constant, positive and negative ones. Now we take Q. Q are the factors of our leading coefficient. Now our leading coefficient, if you notice right here, I'm going to put this in a different color. All right. So Q is going to be green. Okay, and that is our leading coefficient, which happens to be 1. So we do plus or minus 1. Now, from here, we're going to divide all the factors of Q into P. And so what we notice is that if I divide this value, positive negative 1, into every single one of these terms, right here, and here, and here, and here, well, 1 divided into every single one are those values. So all of our possible zeros are actually just our Q values, which are all of these. Okay, so that is P over Q. Since Q is 1, it's just simply going to be the P value or all the possible factors of 36. Now, this is where it gets a little crazy because the rational zero test is what mathematicians would use to find all the possible rational zeros of a polynomial. And once they get these possible rational zeros, they would have to test them. All right, so the second part is once you get P over Q, you need to test P and Q. Okay, you need to test them. And I'm writing this poorly. All right, test these values. So when we look to test these values, what we have to do is use synthetic division, or you have to plug every single one of these in to see if we get a value of, all right, 0. So when you test it, you're looking for P over Q, whatever those values are, plug them into your function, and you're looking for a value of 0. Well, that is very long, that is tedious. So what we're going to do next, in order to make this a little bit quicker, is we're going to actually use our calculator to determine the actual rational zeros. So if you take out your calculator and you go to your y equals, all right, over here, I'm going to punch this in here. And what I have is, and I'm going to pause this for a second as I get this set up. All right, sorry about that. I am back. Obviously, you didn't think I was gone, but I was for a second. And what we have here, and while I was gone, you notice that all of a sudden my values on my calculator changed. Okay, a little weird, right? Well, they did. And I punched this into my calculator, and you can do this through yourself. And now what we're going to do is, once we get this in here, I'm going to go to Zoom 6, and we're going to graph this polynomial. And when we graph this, we're looking for some possible rational zeros. And we're going to wait for this, and we're going to try to see, are any of these zeros any of our possible ones that we found with P and Q? Well, we notice that appears that we have one right here. Okay, when I take this down, it appears that we have one that is located right here at positive 4. Now, to verify this, what we're going to do is I'm going to go trace, and I'm going to punch in 4, press enter, and I should get a value of 0. Yes. So what we just found out is 4 is a possible rational zero. So this positive 4 right here, all right, that we found, the positive 4 is actually a zero of this function. So it's rational. Now, what we're going to do next in this problem is we want to try to determine the remaining complex zeros, because according to the fundamental theorem of calculus, all right, and the factorization theorem and all the other theorems that we know about polynomials, is that it should equal the degree. So the number of complex zeros should equal the degree. All right, and what we have is 3, so we should have 3 complex zeros. Okay, so when we go right here, I'm going to determine what these values are. All right. So I'm going to take this 3, and I'm going to move these values down here. Give myself a little bit more room. Apologize about this. Okay. And I'm going to take and factor out one of my factors. Since I know one of the real factors is x minus 4, I'm going to take this and factor it out of my polynomial. So find the remaining complex zeros. All right. Find the remaining complex zeros. I'm going to take this right here and factor this out. I'm going to use synthetic division. And I have 1, negative 4, 9, and negative 3, 6. And I'll divide this out. And I have 1, 4, 0. That's 0. That's 9, and 36. And I get a remainder of 0. So what I find is that I have another factor right here. All right, looking at this, I can notice that I have x squared, all right, plus 9. So from here, I can factor out this and have x minus 4, which is actually going to be x plus 3i, and then x minus 3i, all right, when I factor this out, okay? Because obviously when you set this equal to 0, just so for those that are following from home, x squared plus 9 equals 0. Subtract the 9, solve for x to get my other zeros, and I have plus or minus the square root of negative 9, which is plus or minus 3i. So they're my other zeros. And I just answered my second question that I have right here. Write the polynomial as a product of linear factors. This is the polynomial as a product of linear factors. Okay, my zeros are 4 and 3i. And so here's my 0. Here's my other 0 right there, which we know is going to equal 4. All right, x equals 4. And then one final question I have, all right, is what do you notice about the imaginary, okay, the imaginary zeros? Well, if you notice that we have 2 of them, okay, in this particular problem, here and here, and you also know that they come in conjugate pairs. All right, conjugate pairs. All right, so they also come in conjugate pairs. And that is true for all imaginary, all right, complex zeros, is that they always come in conjugate pairs. All right, so a little recap of what we just did here. We learned about the rational zero test, which allows us to find possible rational zeros. We can test all of these once we get that and find out if any of them work, all right, by plugging them into the function and identifying if they equal 0, which is right here. However, we can also go in a calculator to identify what these actual rational zeros are, which we did right here. Once we find that rational zero, we can create a factor, which is x minus 4, and factor that out by using long division or synthetic division, all right, from our original polynomial, which is located there. Once we get that, we can find our remaining zeros, okay, when we get that done factoring, and then write out the product of linear factors like so. All right, so I hope this helps you understand the rational zero test. I'll probably have one more lesson and another example in the next tutorial.